The following is the video solution from JSDT Solutions. Question 2.1 says, the first three terms of an arithmetic pattern are -5, 2, and 9. And 2.1.1 says we need to write down the next two terms of the pattern. Okay, so looking at our pattern, do you see that it is an arithmetic pattern? So that would mean that it has a constant difference. So we can just find that constant difference by saying 9 minus 2, term 3 minus term 2, which is 7. And so that means that each term would be found by adding 7 to the previous term. So it means that the next two terms would be 9 plus 7, which is 16, and then 16 plus 7, which is 23. And that is our answer. Okay, moving on to the next question. Question 2.1.2 says, show that the sum of the first n terms of the pattern is given by this formula. So we need the sum of the first n terms. So we're still using the sum, meaning we could use these two formulas. Okay, so any of these two formulas, but you see that we're trying to find the sum of the first n terms, meaning the last term will also just be the nth term. Okay, meaning that Tn equals a plus n minus 1. So we might as well just go with this one. Okay, because we're still going to get to this point. If you say first term plus last term, well, the last term is a plus n minus 1 times d. So it's still going to be the exact same thing. So let's go ahead and use this formula. So we're saying Sn is equal to, we still have n over 2 because we're trying to find the sum of the first n terms. And then 2a, now what is the value of a? A is the first term, and we can see that our first term here is -5. So we're going to say 2 times -5 plus n minus 1 multiplied by d, which we found to be +7. So multiply by +7. Okay, and now we just have to simplify this. So it means that Sn is equal to n over 2. And when we multiply these, they give us -10. And when we distribute here, we're going to get, let's just distribute with the -1 first. That's -7 and then +7n. Okay, and just rewrite it with the 7n being first. So therefore, Sn is equal to n over 2 multiplied by, and we have 7n, and -10 minus 7 is -17. And this is the answer. Just notice that they made that 1 over 2. It just means that there is an invisible exponent of 1 in front of n. So you could have also just rewritten that as 1 over 2 n. And this n would still be a value that is in the numerator because it has an invisible denominator of 1. Okay, so that is our answer. And moving on to the next question. Question 2.2 says, the first 4 terms of a quadratic pattern are x and then 3x minus 5, okay, and so on. So we have 4 terms and they want us to determine the value of x. Okay, so let's rewrite our pattern first. And now, in order to find x, we're going to use the fact that we know that the second constant difference is constant. And so that's where we're going to create an equation. So first, we need to find the first differences of this pattern. So we'll say the next term minus the previous term. So that is 3x minus 5 minus the x. And of course, that's going to simplify. So you see the 3x and the minus x, they'll simplify to 2x. So we have 2x minus 5 over there. We can just rewrite it here. That's fine. And then here we're subtracting 4x minus 3 and then minus this. So that's 4x minus 3 minus 3x minus 5. And when we distribute, we have 4x minus 3 minus 3x plus 5. And then 4x minus 3x is x. And we have 5 minus 3, which is +2. And you see that that simply just simplifies to x plus 2. And then we'll say next term minus previous term. And that's 5x plus 1 minus 4x minus 3. Okay, we're subtracting by something that has 2 terms. So we use brackets. And that is now 5x plus 1 minus 4x. And then that becomes a plus 3. And when we subtract that, that becomes x. And 1 plus 3 is +4. Okay, so we have x plus 4. And these are now our first differences. Okay, so now what can we do with this? This is our first differences of the quadratic pattern. it forms an arithmetic pattern, a linear pattern. So that means that if you find their differences, they will be constant. So whatever this term minus this term gives us is going to be exactly equal to this term minus this term. And so we'll find out by saying this is x plus 2 minus, and now I'm just going to apply that negative into each of these terms. So that's minus 2x, and then minus negative 5 becomes plus 5. So we'll have negative x, and then 2 plus 5 is a 7. So 7 minus x is what we have there. So 7 minus x, and here we're saying x plus 4 minus x minus 2. So you see how the x's cancel, and 4 minus 2 is 2. So we now know that these two should be equal. So our equation here is 7 minus x is equal to 2, and we're just going to solve for x. Transpose the x, it becomes positive. Transpose the 2, it becomes minus. So 7 minus 2 is 5. Therefore, x is equal to 5. And that is our answer. Moving on to the next question. Question 2.2.2 says, if the pattern continues indefinitely, prove that all the terms of the pattern are positive. The main thing that we can use to determine the kind of term values we're going to have is the general term. So we clearly have to find this pattern. So it's in the form of an squared plus bn plus c. Okay, so in our pattern, we're just going to have to concentrate on these three first terms. Okay, in the quadratic pattern, the first differences, and in the second constant difference, given that we know what x is now. Okay, so in each of these, this is what we're going to do. So the second constant difference, we're going to make this equal to 2a. And then the first difference, the first term in the first difference will be equal to 3a plus b. And then this will be equal to a plus b plus c. And we're only equating it to the first term in each. Now, in this one, it's quite simple because we already know what that second constant difference is. So we'll just say 2a equals 2. So if 2a is equal to 2, what is a equal to? A would simply be equal to 1 if you divide both hand sides by 2. And 3a plus b equals 2x minus 5. So this is 3a plus b, but we already know what a is, it's 1. So plus b equals 2x minus 5. Well, x is equal to 5, so that's 2 times 5, which is 10, minus 5, which is equal to 5. So b is simply equal to 5, and then this multiplies and becomes 3, and when we transpose it, it becomes negative. So 5 minus 3 is 2. And then a plus b plus c, but we know that a is 1, b is 2, and then say plus c equals, and it's equal to x, which we know is 5. So it's equal to 5, and so c is equal to 5, and then 1 plus 2 is 3. Transpose it, it's negative 3. So 5 minus 3 is equal to 2. So this is our formula. Our pattern's formula is Tn equals n squared plus 2n plus 2. Okay, so this is what it looks like. Now the question is specifically to prove that all the terms are going to be positive in this pattern. Okay, remember that this is a pattern, and because they're already calling it a pattern and we already know this is a pattern, we need to take into account that with a number pattern, you can only consider n values that are specifically natural numbers. So what I mean by this is you can't have a term number that is a fraction. Okay, there's no such thing as term a half or term negative 3 over 2. Okay, and term negative 2, for example. It's always numbers like 1 and 2 and 3 because these represent positions. Okay, we can have the second position, but we can't have the negative second position. Okay, so because of that, we should already consider that in this, we already know that n is an element of all natural numbers in this. Okay, so we'll just consider that already since this is a pattern. So how do we prove that this is always going to produce positive values if we know that n is an element of all natural numbers? Well, let's go ahead and look at each part of this expression. So we have n squared. N squared, regardless of what n is, even if n was not an element of natural numbers, even if it wasn't numbers like 1, 2, 3, and so on, it would still always be positive because you're squaring this value. So this will always be greater than 0 for where n is an element of all natural numbers. I'll just keep this since we know that n definitely is an element of all natural numbers because we're dealing with a pattern. And we also know that 2n is also going to be greater than 0 because now this is an element of natural numbers. You can only use natural numbers here, but you're just multiplying by 2. So it's also going to be greater than that. So this will conclude that the entire expression n squared plus 2n plus 2, okay, you're just still adding to what is already positive. It will still maintain this. It will still be positive. It's always going to be positive for all values that are natural numbers and even real numbers, really. Okay, so this would be one of the main things because it is a pattern in the first place. Okay, so we could leave it like that. Okay, and that is it for this question. Moving on to the next question. Question 2.3 says, consider the geometric series, and we have this geometric series in terms of p for where p is not equal to 3. Okay, and you can see they said that because if p was equal to 3, you'd have 3 minus 3, which is 0. So you'll just have 0, 0 plus 0. Okay, so that's why. And they're specifically saying determine the values of p for which the series converges. So for a series to converge, the ratio will be greater than -1 but less than 1. So let's find that common ratio, that constant ratio. So we can find that by taking the next term divided by the previous term. Okay, it can be term 2 divided by term 1 or even term 3 divided by term 2. So if we say r is equal to, and we're going to just say term 2, which is 3 over 4 and then p minus 3 all squared divided by term 1, which is 1 over 2 and p minus 3, then what is this equal to? And it's going to be in terms of p. So let's just deal with this first. You see that you have p minus 3 all squared and then p minus 3. So one of it will cancel here and you're just left with p minus 3 here. And so what is 3 over 4 divided by 1 over 2? 3 divided by 1 is 3, 4 divided by 2 is 2. So it's 3 over 2. So we have 3 over 2 and then times p minus 3. We might as well just distribute here. So making this the ratio 3 over 2p, and then that's going to become -9 over 2. Okay, the values of p for which the series converge is where our ratio, which is 3 over 2p minus 9 over 2, is greater than -1 but less than 1. And let's just solve for this inequality. Okay, so with this inequality, in order to solve for p, we first need to get rid of this -9 over 2. So we can do that by adding -9 over 2 on all sides. Remember, these are really just two inequalities, okay? They've just been put as one since the values that it was pointing at were values that were greater than -1 but less than 1. You see that they fall within the same section, okay, within a common interval, really. So now that we have that, so we're just adding 9 over 2 on all sides. And so 1 minus 9 over 2, that's like saying 2 over 2 minus 9 over 2, which is -7 over 2. So this becomes -7 over 2. And then this stays 3 over 2p. And we're saying this is greater than -7 over 2, but less than. And we're saying 1 plus 9 over 2. Again, that's like saying 2 over 2 plus 9 over 2, which is 11 over 2. Okay, and now we just have to solve for p. So to solve for p, we need to get rid of the 3 over 2. So we can do that by dividing by 3 over 2 all through. So, or you could see this as multiplying by 2 over 3. So you can multiply by the reciprocal, because if you do that, it's going to help to cancel out that numerator and the denominator. So we can just see this as multiplying all sides by 2 over 3. Okay, so therefore p is greater than, and when we multiply here, -7 over 2 times 2 over 3, you see that the 2's will cancel diagonally and you're left with -7 over 3. And so p is greater than -7 over 3, but less than, and 11 over 2 times 2 over 3, those cancel and you're left with 11 over 3. And that is our answer. Okay, and also just remember that they did say for where p is not equal to 3. you see that 3 is also going to be included in one of these numbers that it's referring to. Okay, negative 7 over 3 and 11 over 3. When we look within that, you're going to get a 3. 3 could be represented as 9 over 3. Okay, it will be within that. So just ensure that you also tell them P is not equal to 3, like they told us. And that is our answer. Moving on to the next question. And then question 2.3.2 says, if the sum to infinity of the series is 1, okay, determine the value of P. So the sum to infinity is 1. Sum to infinity, the formula is A over 1 minus R. So we just need to find A, and then we already know what R is in terms of P, and we know that the sum to infinity is actually equal to 1. So what is A? A is the first term in our pattern, which is 1 over 2 P minus 3. So tell them 1 over 2 P minus 3. And then R was that constant ratio. You see how we divided term 2 and then divided by term 1, right? So that is our ratio, and we'll just take it like that. And we'll substitute them. It's going to create an equation in terms of P. So our equation is going to be the sum to infinity, which is 1, is equal to A, which is, we might as well just distribute there. So that is a half P minus 3 over 2, that is A, over 1 minus R, which is 3 over 2P minus 9 over 2. Okay, and we're just solving for P. Okay, so to just remove this fraction, just multiply, cross multiply. This is a fraction, okay? It's something over something, so we're just going to cross multiply. These multiply to stay exactly the same, so they just stay 1 minus, and we have 3 over 2P minus 9 over 2. And then these multiply to also just stay a half P minus 3 over 2. So we could have also just used that as an opportunity to distribute here. So that's just going to be minus 3 over 2P plus 9 over 2. Okay, so now we're just simplifying. So this is 1 over 2P. And then if you transpose that, that is plus 3 over 2P is equal to, and we have 1 plus 9 over 2. So 1 can be 2 over 2. So that's 2 plus 9, which is 11 over 2. And now we can transpose this. So this is plus 3 over 2. So 1 over 2 plus 3 over 2, that gives us 2, because 4 over 2. So that's 2P is equal to, and then 11 plus 3 is 14. 14 divided by 2 is 7. And finally, when we divide both hand sides by 2, P is finally equal to 7 over 2. And that is our answer. Okay, and that is it for question 2.